Sim code. Introduction to NumPy and array. NumPy and array is a powerful data structure for numerical computing. Key features: homogeneous. All elements are of the same type. Multidimensional, can have one or more dimensions. Efficient, optimized for numerical operations. Creating arrays. Different ways to create an array. From a list, np.array 1, 2, 3. Using built-in functions, np.zeros, np.ones, np.I, np.arrange. Random arrays, np.random.rand 3, 3. Array attributes. Understanding key attributes of an array. Shape, dimensions of the array. Type, data type of elements. Size, total number of elements. Dim, number of dimensions. Item size, size of each element in bytes. Bytes, total size of the array in bytes. Creating a NumPy array. Code example. The following code demonstrates how to create a NumPy array from a list. np.array 1, 2, 3 creates a 1D array. The print function displays the array. Creating arrays with built-in functions. Code example. The following code demonstrates how to create arrays using built-in functions. np.zeros 3, 4 creates a 3 by 4 array of zeros. np.ones 2, 2 creates a 2 by 2 array of ones. np.I 3 creates a 3 by 3 identity matrix. np.random.rand 3, 3 creates a 3 by 3 array of random values. Array attributes. Code example. The following code demonstrates how to access array attributes. ARR shape returns the dimensions of the array. ARR type returns the data type of the elements. ARR size returns the total number of elements. ARR and dim returns the number of dimensions. Conclusion. This concludes our lecture on NumPy and array. Key takeaways. NumPy arrays are essential for efficient numerical computations. They can be created in multiple ways and provide numerous helpful attributes. Mastering array attributes and creation functions is key to effective usage.